this challenge that you saw and, the solution then you put together. So let's talk a little bit about that. And for those that don't know, and just to be direct about it, what exactly does Victus Technologies build?
Yeah, so pure software,
Okay.
um, and software where the kind of 30 seconds of it to enable what we like to call contested autonomy. So when you're in an environment where it's not perfect, it's not a lab, it's not a nice clean field where it's open. It's in this kind of where we live, right? We live like human activity, whether it's combat or whether it's other activities. Like we live in an environment where there's dust, there's haze, there's buildings in the way, solar flares get in the way, there's all kinds of things like this. So we have to
Yeah.
operate, like that. So what we do, we built a software. That software models how that system works. Whatever that edge-based robotic system is, it models it. And then we put it in a simulator and we perform this kind of like machine learning. It's a very special machine learning and, not to use a bunch of buzzwords, but there's a data ontology that we use and a type of multi-state parameter machine learning we use. That's really our invention. And from there, we're able to model like how it should look when it moves based on gravity inputs. These
Okay.
gravity inputs are from something called accelerometers. The accelerometers are in everything. Your phone does step counts with accelerometers, not GPS. That's how it gets that
Okay.
step count. And it's getting that from gravity shifts. Like it knows how the gravity, it literally detects that from a gyroscope and then an accelerometer. We've trained a model then to allow us to have a very precise location just based off of those inertial systems. The output, we train this then in a synthetic environment, and this is minutes to hours. This is not years or months or years. The output of that is what our provisional patent calls a synthetic GPS. That synthetic GPS then is deployed to the drone or other robotic system, and then it sits on that system. So this is actually important that there's no like connectivity required back to something else. It sits on
Okay.
that drone system, and then it passively receives that raw data and it's received that raw data, and then it updates kind of what we call a state estimator. That state estimator says, where am I? That's what it's doing. It's answering that question, where am I? We then monitor that Kalman filter that we talked about, right? We talked about this earlier. So we monitor that Kalman filter. If we have good GPS, then we do nothing. We just operate in the background. Because when GPS works, it's actually quite effective, right? You get a
Yeah.
location error of maybe a meter, and that's about it. What happens when you take GPS away is that that location error grows and it's not linear. It grows like in a circle like this and it grows quadratically. So it grows very, very fast.
Okay.
After about an hour, a drone will go from a location error of 1 meter to 1.5 kilometers when you remove GPS,
Okay.
jamming or just remove it for whatever reason. That's it. So it's no longer usable, right? So what
Yeah.
we do then when we detect that's happened, we then use our machine learning pre-trained state estimator and we transmit that information to the Kalman filter. We do it in a way that the software architecture is expecting to see. That
Yeah.
then enables it to work in basically any software architecture. So you don't have to change it. So for those, anybody listening that's, into drones, if you're using PX4, ArduPilot, Pixhawk, some of these basic standards for the autopilot or the architecture, we work with all of those. There's no modifications or rollbacks or new APIs needed. So this is new kind of reference architecture that works with whatever hardware software condition that you have. And then it enables that device to operate without a GNSS signal from the GPS constellation. That's the kind of net, the net gain. So what you have, if you take a system that was going to have to work over in, was going to have to work in Ukraine or was going to have to work in some other environment like that, and then you're operating that environment, all of a sudden it doesn't work. The idea is that we take that drone, we put it through the system, and all of a sudden it can work in there with no real changes to that system.